The notion of work and force can also be applied to springs. But in this situation, we use Hooke's law, which states that the force required to maintain a spring stretched x units past its natural length is proportional to x. And in this situation, the force function is f of x equals kx, where k is the spring constant, and x is the distance in which the spring will be stretched. An example of Hooke's law is as follows. A force of 60 newtons is required to hold a spring from its natural length of 4 meters to stretch it to 12 meters. How much work is done stretching it from 5 meters to 15 meters? To do this, we must apply it to Hooke's law of f of x equals kx, in which the f of x is the 60 newtons required to hold it, k is the spring constant we must solve for, and the x is the distance in which it is stretched past its natural length of 4, which is 8 meters. So we solve for k, dividing 60 by 8. We get k equals 7.5 newtons per meter, which we then plug into the Hooke's law equation. So f of x is equal to 7.5 x. Then we go back to our previous example of variable force and work using integrals. So the integral is of the distance stretched past the natural length of 5. So 5 minus 4 is just 1. And then 15. So 15 minus 4 is 11. Then we plug in the equation we just got from Hooke's law of 7.5x and tag on a dx, as it is an integral. Once all the math and the numbers have been crunched, it comes out with the answer of 450 Newton meters, which is the force required to hold the spring.